Good afternoon, everyone. In our last class, we have discussed about the movement of the Earth, the proof of the Earth revolutions, and the effect of the Earth rotations. We are going to continue the class, the effect of the Earth rotations. We are going to discuss one by one. So, rotations. Due to the rotations of the Earth, there is a effect like the formations of the day and night. Days and night are mainly caused for the due to the rotations of the Earth and. As you know that one complete rotations of the earth it takes 23 hours 56 minutes and 54 seconds. Okay, and we totally call it the 24 hour, right, to one complete one rotations of the earth, so on its axis. So one complete rotations of the earth that makes during the rotations the which part actually come to the faces to the sun, that gets the sunlight, so they have the daytimes. Okay, and the other part which is opposite of the sun, they have the darkness, so that's why they are the night. Okay, so the imaginary line that the separate the lightened part and the darkened part, that is known as the shadow circles, or it is also known as the circle of illuminations. Okay, and next we are going to discuss that down in the period of time, or the time of the day before sunrise, when there is a faint light you can see in the sky, that is another time. And in the evening, before the evening, the part of the earth which reaches the light part after crossing the shadow circles, that experience down. Okay, so dusk or down, these are the two things you know. Next one, we are going to discuss on the what are the Coriolis effect. Due to the earth's rotations in anti-clockwise directions, it produces a deflective power, okay, on a moving body on its surface. It was first discovered by and Coriolis, okay, in 1835. So what is that? By this Coriolis effect, by this force, it can object moves in a straight line from the north pole towards the equator will appear slightly deflect to the right, and yeah, this is the due to the earth rotations. Okay, you can see in the northern hemisphere, due to the Coriolis force, the wind and the trade and the tides, they will move right hand side in the northern hemisphere and left hand side in the southern hemisphere. This is also due to the, according to the Coriolis, according to the Ferrell's also said that the wind and the ocean's currents, they moving poleward to the equator. As you know that the lighter wind or the lighter ocean's current, they will move, or the warm ocean's current, they will move from the equator towards the poles, and the cold or the heavy wind and the ocean's current, they will move from the pole towards the equator. Okay, and here you can see they will deflect it. Okay, due to the Coriolis force, they will deflect it, like the ocean's current and the winds, they will deflect it right hand side in the northern hemisphere and left hand side in the southern hemisphere. So the wind at all the latitude to the north of the equator, in the northern hemisphere, deflect to the right of their intended path, and in the southern hemisphere they will deflect in the left if their intended paths. Okay, now next one we are going to discuss about the inclinations of the earth axis and its significance. So the earth axis of the as you know, the axis of the earth is an imaginary and slightly line which is passing the center of the earth and joining the south pole and north pole. Okay, these two poles. So the earth rotates about in axis, and every 24 hours, not exactly in 24 hours, it takes maybe 23 hours 56 minutes and 54 seconds. Okay, and it tilted at the angles of the 23 and half degree. Okay, and the vertical vertical, okay, 23.5 degree verticals, it will always tilted, and at the angles of the 66.5 degree from the earth orbital plane. Okay, so this is the two thing you need to know. One is the earth tilted at the angles of the 23.5 degree, and it's also from the vertical, and the angle that is 66.5 degree from the earth orbital plane. So during the revolutions of the around the sun, the earth axis remain inclined at the same angle, that is 66.5 degree to the plane of orbit. Okay, in all positions you can see in the orbit of the, or the axis of the earth points the same directions to the polar star in the northern hemisphere, and the here's the Hadley's octant in the southern hemisphere. You can see in the both same direction, you can see this. Now what are the significance of this inclinations of the earth axis? So here the significance, right? Due to this, the changes in the positions of the midday sun at the different times of the year, you can see, also varying the length of the day and time. As you know that each and every place had the morning time and sunrise time and sunset time is different, and the length is also different. So the varying the length of the day and night at the different time of the year, you can see. During the winter season, the days are short and the nights are long. During the summer season, the days are long and the summers are nights are short, you can see. And also due to these reasons, there is a changes of the season, we can see. Okay, so these are the mainly effect of the earth rotations. Now we are going to discuss next one is the revolutions. So what is the revolutions? Revolutions means the movement of the earth around the sun on a fixed path. Okay, that is the revolutions. The earth revolutions around the sun is an anti-clockwise directions on a fixed orbit, that is it's take 365 and 1/4 days. And also that means that it's take maybe 365 days, 5 hours, 48 minutes and 46 seconds. Okay, and you know this full one revolution, that is called a year, and it is also known as the full movement, the annual movement of the sun of the earth, annual motions of the earth is known as the complete one motions is known as the solar year. So what is the speed of the revolutions of the earth? The earth complete one revolution on its orbit is in total it's take 365.2422 solar days. Therefore its speed of the revolutions of the earth is 30 kilometer per second. Okay, just remember 30 kilometer per second. Then what are the effect of the this earth revolutions? Number one, this is the one is the leap year. One is the leap year. Okay, the earth takes 365 and 365 days, that means 365 days, 5 hour, 48 minutes, 46 seconds to complete one revolutions around the sun. So what is we say that 1 year means 365 days, right? 1 year means 365 days. Then what is leap year? This 1/4 days, 5 hour, 48 minutes and 46 seconds. Where is it is gone? It is actually calculated as like the 4 hour extra 4 6 hour, you can say. Every fourth year, one complete day, that is the 6 hour into 4 equals to 24 hour, or they add to the year which has the 366 days. Okay, after every 4 year. Okay, so the extra day is added to the 28 days in the month of February. So February month, therefore they will have the 29 days. Okay, so this type of year will having the 66 days which have the 28 days in a February month. They are the called leap year. Leap meaning jump. Okay, so this time component which is complete the one revolution, that is 365 days, 5 hour, 48 minute and 46 second. This every 5 hour, 48 minute, 46 second as a additional 6 hour, and after every 4 years it will added extra 1 day. Okay, and every 4 year you can see, after every 4 year you can see leap year. Now next one is the ephelion and perihelion. Here we can know that what is ephelion and what is perihelion. Here you can see just distance from the average distance from the earth and sun, that is 152 kilometer per million kilometer. This is the average distance, but on a particular day the earth come very near to the earth come very near to the sun, and on a particular day the earth gone very far away from the sun. In these two particular days is known as the ephelion and perihelion. So which day it is? The day on the earth, that is ephelion, which is meaning away, and helions means the sun. So it is the day that is July 4. Okay, the normal average distance is 150 kilometer million kilometer, but on July 4 when the sun goes very far away from the sun, when the earth goes very far away from the sun and its distance is 152 million kilometer, that day is known as the ephelion. Okay, and January 3, that time the distance of the earth and sun is very least, where that time its distance is only 147 million kilometer, and earth come very near to it. So this particular date is known as the perihelion. Peri means near and helions means sun. So the average distance between the sun and the earth is 150 million kilometer, but during the 4th July it is 152 kilometer, that is ephelion, and during the 3rd January it is very near to us, which is 147 million kilometer, that is known as the perihelion. Okay, so next one we are going to discuss that what will happen, the yearly apparent movement of the sun due to the revolution. During the year the earth makes one complete revolution around the sun, and due to that reason the sun is a stationary object in the solar system, and it is the positions is the sky apparently appear and hues northward or the southward annually. So this is called the annual apparent movement of the sun. Okay, so what are the causes for the apparent movement of the sun? Number one, the plane of the earth orbits, that is called elliptical. Since the earth orbits the sun appeared to us that the move around the sky in elliptical. We can see every time the sun is going from here to there, from the east to the west during the morning. It is only because of the earth elliptical shape and earth moving around the sun we see like this. Okay, also the earth axis tilted at the angles of the 66.5 degree to the plane of the elliptical. So this is the also reason for the yearly apparent movement of the sun. And also the earth axis remain parallel to itself in the all positions on its orbit around the sun. So it's happened as the axis always point to the north star in the northern hemisphere and headlies octane in the southern hemisphere, only because of the inclinations of the angle at the 66.5 degree to the plane of orbit. Okay, and also the subsolar point that is varies during the revolutions. The overhead sun therefore appeared to move forward from the topic of Cancer or to the topic of Capricorn, and from the topic of Capricorn to the topic of Cancer back during the revolutions. Okay, and now the next one is the variations in the length of day and night. Due to the rotations of the earth we see that there is a formations of the day and night now, but due to the revolutions of the earth we see that the length of the day and night is changes. So how the earth revolutions around the sun in an elliptical orbit is depending on the amount of the durations of the light received during the areas of the different length of the day and night. Sometimes the days are long than night, sometimes the nights are long than days. Okay, it's varying the length and day and night the experience all over the world except the equatorial regions. Every time equatorial regions have the same amount of the days and night. Okay, but during two times on 23rd September and another one is the March month, okay, 22nd March. These 2 days, our Earth is positions in the orbit at all over the Earth. They will, the length of the day and nights are the same, okay, mane both day, the light, the days and the night are the same. So these are the mainly the effect of the mainly the effect of the revolutions of the Earth, okay. Next we are going to discuss about the what are the in next class we are going to discuss about the different positions of the earth, okay, due to that reasons what type of season we see, okay. I hope you understood this topic. If you have any queries, please comment below, and if you like my video, please give a thumbs up, and please like and subscribe my channel. Thank you.